All right, so what we're going to look at here is the quadratic formula. Now with the quadratic formula, the nice thing about this, in the last few videos we looked at solving quadratics by taking square roots, solving quadratics by factoring. We didn't actually get to completing a square, but by factoring. And the thing about factoring, though, is sometimes you might run into a situation where something might not be factorable. In other words, we won't be able to solve it. With the quadratic formula, we can solve any quadratic, no matter what we're looking at, using this equation, okay? And actually, I broke it apart into two equations here, but we'll write it as one equation here in a second. It's just the way I had to type it in to the program. Then with the quadratic formula, the other nice thing is because we worked with simplifying square roots, we also ran into something called the imaginary unit, right? So every once in a while, you might be solving a quadratic, and in this particular set of notes, and particularly in the problems we're working on, you're probably not going to run into it now. But later on, if you get into Algebra 2, that's something that's going to reappear, where you're solving a quadratic and you're going to run into the imaginary unit, okay? So the quadratic formula is just really nice because it's a nice simple equation that we can take the a, b, and c of our equation, like we talked about with factoring, and plug it into the equation and then simplify and solve. Okay, so let's kind of dig into it. This is a process that we want to go through here. Is we are going to identify the a, b, and c, like I just mentioned, of the actual equation, just like we did when we were talking about factoring, the a, b, and c, the coefficients, and the constant. And then we're going to take that a, b, and c and plug it into the actual equation. Now, I broke this apart as two equations because of the software, but as one equation, okay, this would be written as a negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? So the only difference here is there's going to be two answers, okay? So this has a plus and this has a minus. That's the only difference between those. And normally we just write it together, like a plus or a minus, as it's one equation, okay? But the thing is, because we have a plus or a minus, we're going to usually get here two answers here. Once in a while, maybe you'll get a single answer because maybe it's like a double root, okay, or something along that lines. But what we're going to be looking at overall here, in general here, is we're going to have two answers. We're going to take a negative b plus the square root divided by 2a, and a negative b minus the square root over 2a, okay? So let's kind of after we plug it in, we're going to simplify it, simplify the numerator, simplify the fraction, and then write our two solutions. But let's go ahead and jump into some examples here. Let's maybe try a couple examples that might be a little bit more simple, and then we could try some examples that we're going to have to actually simplify the square root. So in this example here, the first thing we want to do is identify the a, the b, and the c. Okay, so our a here is 1, b is 3, and c is a negative 10. Now that's important. Make sure you include the sign, okay? Make sure you include the sign. Then what we're going to do is we're going to plug that into the equation, okay? So usually what I like to do is write the equation first so I know what I'm plugging it into. We have a negative b plus or minus b squared minus 4ac all over 2a. And wherever we see a b, we're going to put a 3. Wherever we see an a, we're going to put a 1. Wherever we see a c, we're going to put negative 10. So we're just going to plug in the numbers into the equation. So we have x equals a negative, okay, b is 3, so this would be negative 3 plus or minus. While we're working on this, what if this were a negative 3? What would happen? Well, two negatives would actually make this into a positive. If we had a negative of a negative 3, that would change into a positive 3. But just keep in mind that might be something that you run into. But let's keep going here, okay? So if I plug in 3 into b, we'd have 3 squared minus 4 times a. A is a 1. I usually like to write it in parentheses to show we have multiplication. Then c is a negative 10, okay? All over 2 times a, which we said is 1. Okay, so that's the first part of the process here, is identify the a, the b, the c, write your equation, plug a, b, and c in, and then after that, that's where these steps come in, where we're going to start to simplify things, okay? So I would start by simplifying everything that's in the square root, and then simplify the square root itself. And then once you have that, you can simplify the top, the numerator. And then since we have division there with the fraction, okay, simplifying the fraction. And then after that, after you simplified everything is as neat as it can be, then we can write our two solutions here, where we have that -3 plus whatever divided by the denominator, and -3 minus whatever divided by the denominator, okay? So let's kind of break this up here. We can kind of move it over here. I'm going to start it up here. So we have x is equal to a -3, or yeah, a -3 plus or minus. Let's simplify the inside here, okay? So the 3 squared is going to give us a 9, right? And then we have a -4 times 1 times a -10. Well, you might say, well, isn't that -4 times 1 times a -10? Yes, but here's what I would do. I would treat this like it's a -4, because then you're not going to make a mistake with the sign. So let's treat it like it's a -4 times 1, which would be a -4, right? Times a -10. Two negatives would then make it a positive, so we get a positive 40. So if it's a positive, we're going to put plus 40. Okay, so I would always just include that -4 and then multiply it through. And then if you get a positive, put plus that number. If you get a negative, put minus that number. Okay, all over 2a, which 2 times 1 would be 2. Okay, so let's just keep simplifying here. So then we have x. I'm actually going to move this out of my way now. Maybe we can just show that we went over here with it. So now we have x is equal to a -3 plus or minus 9 plus 40 is 49 over 2. Then x is equal to a -3 plus or minus. Can I simplify that square root? Yep. What is the square root of 49? 7, right? 7 times 7 gives us 49. So now we've completely simplified the square root, and we took care of the 2 times 1. So now let's simplify the numerator, and then we can simplify the fraction, okay? So what we end up with here is we have a -3 plus 7 over 2 and -3 minus 7 over 2. There's really two answers here, okay? There's x equals a -3 plus 7 over 2, and then x equals a -3 minus 7 over 2. So I know it says simplify the numerator, but that's really what I'm referring to. Maybe we can even kind of change this and say break. I mean, sometimes you might have to actually simplify the square root more, but you could add to this and say break into two equations. Okay, so now we have a -3 plus 7 and then -3 minus 7. So we can simplify the numerator now, and then we can simplify that fraction. So we have x is equal to a -3 plus 7 is 4 over 2, right? And then a -3 minus 7 is -10 over 2. So now the top, the numerator is simplified. Now we can simplify the fraction to get our two solutions. 4 divided by 2 is 2, and x is equal to -5. Okay, so this is simple as we can be, and this would be our two answers. Okay, so that's one example like that. Let's maybe try one more here that's kind of simple, and then maybe we could try one or two examples in which we have to simplify the square root. Okay, so again, first thing that we're going to do here, let's look at number 3, is you identify the a, which is a 5, b, which is -8, and c, which is -4. Okay, don't forget the sign. Then we have the equation x equals plus or minus square root of b squared minus 4ac. Whoops, I completely skipped over -b over here, didn't I? Let's go back. -b plus or minus b squared minus 4ac all over 2a. Okay, and then x is equal to a -b. Okay, so notice this is kind of what I was talking about earlier. B is already a -8, so if I have a negative of a -8, what is a negative and negative going to give us? A positive, right? So whatever they give you, basically you're just going to change the sign there. Plus or minus b squared, so b is a -8, so it'd be -8 squared, minus 4 times a is 5, times c, which is a -4, all over 2 times a, which is 5. Okay, so now we plugged it in. Let's go ahead and try to simplify this. I'm going to kind of move it up here to this space at the top. So we have x is equal to 8 plus or minus square root. What's a negative 8 squared? Negative 8 times a negative 8 would give us positive 64. And then here, again, treat this like it's a negative 4 times 5 times a negative 4. So we're still looking at this guy down here, right? So a negative 4 times 5 is a negative 20. And then a negative 20 times a negative 4. Two negatives make a positive. And we're going to get positive 80 all over. 2 times 5, we can simplify that as 10, right? So then we have x is equal to 8 plus or minus. Let's simplify the square root. We have 64 plus 80, which gives us 144 over 10. And we have x is equal to 8 plus or minus square root of 144. We can simplify that, right? That's 12 over 10. So now we simplified the square root. Let's simplify the numerator, break it into the two equations, and then simplify the top, and then divide with our fraction there, simplify the fraction. So you'd have x is equal to 8 plus 12 over 10, and x is equal to 8 minus 12 over 10. Okay, so the two equations there. So we have x is equal to 8 plus 12 is 20 over 10. And then x is equal to 8 minus 12. That, I have different sign there, so we have a negative 4 over 10. So it's okay. Notice we're going to get a fraction on that second one. That's okay. You can get a fraction. So then we get x is equal to 20 divided by 10. Simplifying the fraction, we get 2. And then simplifying this guy, what goes into 4 and 10? 2 and 5, right? So we're going to end up with a negative 2 and 2/5. So 2 goes into both of these. 2 goes into 4 twice, and 2 goes into 10 5 times. Okay, so this would be our two solutions. All right, so those would be the more simple ones. But then sometimes, let's look at an example like maybe, which one of these has a fun answer we can look at here? Let's look at one like maybe number 6. Okay, so number 6 here, let's look at this guy. And this is going to simplify, but the square root isn't going to be able to, it's not going to be a perfect square. So we're going to have to simplify the radical as much as we can. And then if it doesn't simplify any further, we're just going to leave it alone. Okay. So with this, again, we're going to start out with a is 3, b is a negative 2, and c is a negative 2. Write the equation, x equals a negative b plus or minus. We have the square root of b squared minus 4ac all over 2a. Plugging in our b is a negative 2. Notice it's a negative, so a negative and negative are going to make a positive 2. Plus or minus b squared, negative 2 squared, minus 4 times a is 3, and c is a negative 2. All over 2 times a, which is 3. Okay, so now we're going to simplify the square root as much as we can. So we get x equals 2 plus or minus negative 2 squared. Negative 2 times negative 2 is 4. And then again, multiply that negative through. So negative 4 times 3 is a negative 12. Negative 12 times a negative 2. A negative and negative make a positive. And then we have 12 times 2, which gives us 24. Okay, then at the bottom there we would have 2 times 3, which gives us 6. Okay, so now simplifying it further, I'm just going to bring it up here. We have x is equal to 2 plus or minus square root of 28, right? All over 6. Now look at the square root of 28. Is 28 a perfect square? No. So this is where our simplifying square roots comes into play. We're going to break this apart and simplify the square root as much as possible. What goes into 28? Well, 4 and 7, right? And 7's the stopping point for us, right? It's a prime number, but can we break apart 4? 2 and 2, right? So now we've broken it down as far as it can go. So just like we talked about before, we're going to replace our square root of 28 here with its simplified form, its simplified radical. So we have x is equal to 2 plus or minus. We had one double, so a double goes into the front. And then we had one single, so that goes inside the square root, right? All over 6. Okay, so that's as simple as it can get. And you might say, well, Mr. Pinkster, if we break this apart into two equations, we can't add with the square root, and you'd be correct, okay? So that's why at this point with these types of examples, we're actually not going to break it into two equations. We're just going to try to skip this step here. I mean, if you can simplify anything further, like the square root, simplify it further. But essentially, we're going to skip the whole breaking into two equations, and we're just going to focus on simplifying the fraction, okay? And the two solutions are actually going to be written like it's one solution, but it's actually two answers. And I'll show you that in a second. So here, what we're going to look at is, notice, when we have 2 plus 2 square root of 7 and 2 minus 2 square root of 7 over 6, what we can do here is we can see if there's a number that goes into 2, 2, and 6, okay? Now, you can leave it like this, but I'm going to just show you what I mean here. Really, if we wrote 2 plus 2 square root of 7 over 6, really what that means is 2 over 6 plus 2 square root of 7 over 6, okay? Really, that's what it means, and we're going to simplify it. But I don't want to get too complicated with you guys. I just want you to focus on the actual fraction here and think about, is there a number that we can go into 2, and into 6? In other words, a number that we can go into those guys, okay? Well, 2, right? 2 goes into itself once, and goes into here 3 times, okay? So anytime you're in this situation, check to see if there's a number that goes into those, and that's how we're going to simplify this. I mean, it's based on what I was just showing you there, but just to make it simpler, that's what we're going through here. So we have 1 plus 1 square root of 7 over 3, okay? Now, this would be as simple as we can be, and this would be our solutions, okay? This would actually be the two answers. You can leave it like this. We know that this means 1 plus or minus 1, or excuse me, let's break it apart into the two equations. 1 square root of 7 over 3, and x equals 1 minus 1 square root of 7 over 3. Okay, we know that that's what it means, but you don't have to leave it like that. If you can't go any further, then this would be our solution. Okay, so this would actually be our solution. All right.